Okay. All right, make sure you have your attendance taken. All right, because the environment is not so conducive, so I'll try to make this a quick session, right? So that you have time to ask questions, or even, let's say, if you want me to check your assignments and so on, so we can actually do that later. Don't worry, okay? So another important fact is that this thing is keep on happening, right? Ever since we have our lecture here, almost like every week we have problems. All right? Okay. So make sure you sign in your attendance, and then I'll also show the code 10 minutes before the end of the class. I intend to end it by 7:15 or 7:20, so that we have more time to go through other issues. All right? Okay, so firstly, have you all started coding? Not yet, right? Are you okay with JavaFX or Java Swing? Which one do you prefer? Okay, never mind. If you are talking about Swing, in fact, have a look at the materials given. In fact, I've made some recording for the Swing and AWT today. Right, and those are available on over here, Lab 7, Swing. So if you want to listen to the recording, it's available here. So at least it gives you a better understanding, as what we have actually taught in the lecture is basically is mainly on JavaFX, right? But for Swing, please listen to this recording here. Then you should be able to look at more on the Java, AWT, and Swing. How do you actually use them together, right? So there's a recording for this one that you can refer to. And on top of that, are you okay with JavaFX anyway? How many of you are still not able to use JavaFX? Can you generate the simple application? Right, before we even talk about the structure of your JavaFX, especially in the version 2, where we separate the files into FXML, as well as controller, and also your code, all right? So if you're okay with this one, then at least you know where to find all those information. If not, then that's where you need to have additional help, right? Additional help are available below. If you have a look at Java and JavaFX programming setup, there's another part for JavaFX references. So these are all the reference book that is available for free, the ebooks, okay? So you can read all these things. And if you still cannot figure out, then you can just come and see me, right? For any additional guide and so forth, all right? And on top of that, I guess one of the important things that we want to mention here will be, in terms of your assignment, right? Assignment, have a look at the assignment part below. Right, so for the assignment, I've added some FAQ here. If you have questions, feel free to actually refer to the FAQ, right? So the FAQ, in fact, will tell you more information about things that are frequently asked, okay? Because it's so frequent, so therefore, it's better for me to put up an FAQ to answer all your questions, okay? So all the answers are here. Please refer to them, and then you should be able to get more information, right, from all those things, okay? All right? If you have any other questions apart from this 15, let me know. Then I'll put them in the updated FAQ as well, all right? So it's available here. Any questions you want to ask, they are here, all right? And another question is about the submission link. The submission link is not in here, but rather it's in your coursework below. So if you go to your coursework, assignment 1, group project submissions, there are 4 parts. In fact, 3 parts are examinable. 1 part is basically for record keeping. So part 1, analysis and design, 30%. 20%. This is the submission link. Okay, it's a turn it in checker. So therefore, if you want to submit anything here, all you have to do is just make sure you submit them from this link. Okay. All right. So if you use this link to submit, then you should be able to submit your assignment, right? So as a student, you will see a different screen from mine. Here, what I see is basically the number of student submissions and so on. But on your part, you should be able to see a button for submit, all right? So let's say for turn it in students, this is what you're going to see. Okay? All right. And the submission inbox will be something like this for us to know that you have submitted something. There's only three times you can submit, okay? Remember that. If you want to do, let's say, plagiarism check and so on, make sure you do it within that 3 attempts, okay? And marks available for this one will be 20. The second part on development, the marks available is 30. And then presentation is 10%, right? And remember to submit accordingly, right? So if, let's say, you are submitting part B later on 15 July, then make sure you submit them using the right link. Okay, don't submit using part A. I won't be able to see it, right? Okay, so part B. Then part C will be your presentation. You just need to submit the slides, right? The marks will be given based on our face-to-face presentation, okay? And then lastly, there's one submission for source code. This one is not given any marks, but if you don't submit, you don't get the marks. Right? You don't get the rest of the marks because you didn't actually submit the so-called source code to us. Right? Remember to split them accordingly, right? Part A is part A, just specification, right? The development. All right? And then analysis design, part 1. Part B, development. Part C, presentation. Make sure you have them. All right? And what else? Okay, so once you submitted, I can see that. Do I have to submit for a group project? Some students will be asking, okay, since it's a group project, must we submit 1 copy or everyone each one? So I would prefer 1 group, 1 submission, all right? And the rest of the group members will get the marks, don't worry, because I can actually grade it from here, okay? I can grade the marks from here. And as long as you have indicated your so-called partners, if you don't indicate the partners, I won't be able to mark, all right? And I won't be able to give all the marks to the project. So make sure you have all these things, all right? Okay, so I'm not in edit mode, so I won't be able to edit, don't worry. Just a safety measure. All right, so for those who just came in, please sign in, right? Make sure you have all your attendance taken. Right, for your assignment, any other questions that you would like to ask? Okay, ready? So when is the due date? Still remember the due date or not? Okay, 28 June. Sorry, not 28 June. So this is the example of source code posted. Okay, never mind. That's the due date. Anyway, the due date for, all right? So sorry about this one. I think the source code, I didn't actually update it correctly. It's not June, okay? It's towards the end after your presentation, 27 July. All right? So let me just modify that part. Okay, so the source code, July, not June, okay? I will have to change it from the settings. Where's my settings? All right. Okay. So remember that each part will be due separately. This one should be after your submission here, which is 27 July. Okay. And that should be 1 day after. All right? We can open this from June onwards. I think it should be fair enough. Right, so 15 July, sorry, July 15. Or even after you finish your part 2, right? Part 2, your development, then 15 July should be open. And you can submit ASAP for this part, right? In fact, given a choice, I will make it earlier. All right? So there are 4 parts altogether. Make sure you submit them, okay? In order for you to get your final grade. The submissions are mandatory. Okay? So let's have a look at it again in plain view. All right, so source code, you need to submit them by 28 July, right? Then presentation by 27 July, submit your PowerPoint slides, okay? And then your part B will be due on 17 July. Part A, 24th June. That means on this coming Sunday, right? Sunday, after Sunday, it becomes Monday morning, AM. All right? Okay? So remember the due dates. Hopefully you can remember it. And then let's start by looking at our lecture slides for today, right? So for this week, in fact, we are supposed to cover binary I/O as well as something called serializable. I think we have covered this in the tutorial. For those who have not, in fact, you can just refer to the tutorial topic that I've actually uploaded. Just go to your tutorial, and it's available there. And because the tutorial is before your lecture, this is something weird, right? I would prefer the lecture to be on Monday, and then the rest of the tutorial can just go accordingly, right? Whereas I don't know the reason why they put tutorial first before the lecture. Lecture is on the last day, the last hour, in fact, of the week. And that makes the whole thing more difficult. So anyway, I have this tutorial on binary file I/O. Please open it up and then, okay. Okay, so let's have a look at your tutorial number 8. Okay, so tutorial number 8. So for covering binary files, why is it important? Because in your assignment, if you have a look at your assignment again, let me just show you your assignment. So for your assignment, basically, there are parts that requires you to use the skills that you learn for binary file. Okay, so one of them will be a bonus given whenever you apply binary data storage in your assignment, right? That's for part 2. Part 1, don't worry, we are not going to examine this yet. Okay, your part A is basically document specification, right? So you're writing about the specification for your game. And then for part 2, during implementation, we would like to see how you store your data. So implementation of persistent storage is basically a given mark, because as long as you save a file, persistent storage is there, right? So whether it's a text file or whether it's just a normal file and so on, doesn't matter, right? As long as you save something, right? And then maximum marks will be 3 if you implement persistent storage with binary data. So binary data is what we are going to learn in our tutorial number 8, okay? So that will give you some idea on how to actually implement it, okay? And then on top of that, anyway, if you are able to implement encryption, that means to hide your username or password from public view, right? Because if you save a text file, it's going to appear in the clear, right? So it's purely textual, and people can see that, okay, this is your username, comma, password, and that's not a good idea, right? So you need some form of encryption, whether it's simple substitution of characters or any encryption algorithm, like for example, triple dash or AES or whatever that you apply to it, that's fine, right? But that will be additional bonus. So that's why this is actually extra, right? It's not compulsory, but if you have it, you are going to get extra marks. So I'm going to look for all these important topics to give extra marks for you. So that means
maximum 4.
Maximum you can get additional 4 marks apart from what you get for your assignment, right? So additional part 2, you will be able to get 4 extra marks. So one of them will be binary data. Okay, so let's jump to. Okay, so many things I'm doing, right? Okay, so for tutorial number 8, okay, we are going to create binary data using file input stream. Okay, so this is for reading the file. Okay, file input stream is for reading the file and the content. File output stream is to write to a file content in binary. Okay, all these are binary libraries. Okay, and then data input stream and data output stream also works about the same way. It's just the method that you call it will be different. Okay, so over here, if you look at this,
all right, so it's all here. Whatever we want to cover in the lecture, in fact, up to the part where we have serializable. So examples are given, and then because if you look at the lecture slides, unfortunately, the lecture slides are not so informative, right? So the lecture slides are not so informative, and because of that, then you won't be able to see example codes here and there. So by right, for this topic on binary I/O, right, binary data I/O, you are supposed to learn about file input stream, file output stream, data input stream, output stream, object output stream and object input stream, serialized data in the serializable format. For those who have actually attended the tutorial, some of the tutorials I've actually demonstrated it, right? But if not, then you can always refer back to the tutorial recording for this particular topic, because the tutorial will cover more than what is mentioned in the lecture slides. Right? Example codes are given rather than just telling you, okay, this is using a primitive print writer like what we did last time. So for print writer, in fact, you can just use print writer output is assign a new instance of print writer with a file path, right? You can specify a path of a file like this, temp.txt, and then just use the standard output format, right? Using print or print line. And then you can just write to a file as though it's a printing to a screen. Right? So then, after you have done this, then this will be standard I/O anyway. And then if you compare with binary files, of course, the binary file format is more efficient in the sense that for numbers especially, when you save it, you are going to get benefits in terms of the reduced size in the file format, right? In the number format as well, right? And then if you look at binary text input-output, right? Binary file normally will be in binary format, right? So that means it's ones and zeros. But when you read it using, for example, a text editor, you are not able to read the content for sure, okay? If you try to open it with a text editor. The better way of reading the content in binary will be to use a so-called hex editor, H-E-X, okay? Hex editor allows you to read the content and then display it in hexadecimal format. Each byte will be represented by the 2 digits in your hexadecimal format, right? So that's why it's much better in that sense. If you use a text encoding, of course, the text format will be like this, 199, you use 3 bytes, right? But if you are going to save it in our binary, a binary number is just 1 byte only, right? So it's 0xC7. C7 represents 199. Much easier, right? As compared to 3 bytes. Okay, hex 31 stands for 1. Hex 39 stands for 9. These are in our ASCII format, right? ASCII format, you're going to use 1 byte each for every digit. So that's a bit wasting, right? You notice that. So that's why using binary I/O classes, we are able to read and write in binary. And one good thing about binary data is that you can mix the binary data in terms of number, string, or even float or double, right, into one
continuous file. The challenge is that you must know the format, right? So although you can save a lot in terms of the file storage space and so on, the important challenge will be that you know precisely how much you allocate for each and every one of the storage. What is the format, okay? If you don't know the format, you're going to end up with trouble, okay? So then we are looking at the first example of input stream and output stream. So input stream, of course, you have your methods that allows you to read or write. Okay, in this case, for input stream, reading the data, right? So you can read one single integer, or you can read in terms of a byte array. So there are a few ways you can read it. So if you read a byte array, of course, the content will be in byte array. So therefore, you must actually pass an input parameter, in this case, as byte array, B, okay? And then the return value will be integer anyway. So don't worry about all these methods. The methods are going to be covered in the tutorial, so I'm not going to cover in detail here. So the next one will be, of course, your output stream. For output stream, it's normally used to write your file, right? So for writing your file, definitely it has methods that allows you to write, or methods that allows you to write in some format, like writing integer, writing a byte array, and so on. So don't worry about this. Also, it's available in your tutorial. Have a look at your tutorial questions or the tutorial lab sheet that we have there. Then you should be able to see how all these things are put together, right? Because I think over here is too theoretical. It shows you too many information that you don't need, and you get stunned, right? Because in order to learn, it's better to start by looking at the code, okay? So these are one pair, file input and output stream. One is to write a file, the other one is to read back the content from the file. So this will be one pair. And of course, for input stream, of course, you can specify a file name or a file object. If you want to pass in a file object, you must create a new instance of a file by passing in either the path, which can be a relative path, or a so-called fully qualified path, okay? So if it's a fully qualified path, then it's an absolute path, right? Then, therefore, it allows you to actually create a file object that can be accessible. If it's not readable, then you get a file not found exception, okay? So therefore, it's better for you to open and close your resources in a try-catch loop, right? You remember the try with resource that we have studied in chapter 1, right? Try with resource. So you can apply that concept here when you are using file input and output stream, okay? So especially for file input stream, because you are trying to read from a file, so therefore you must know. File output stream is at least quite safe in the sense that even if the file is not there, it will create a new file, right? Most of the time, a new file will be created. So you are not going to face much problem in file output stream, but in file input stream, you are going to get problem if the file name is non-existent, okay, in certain path. Right? So this is one example. Using a file output stream to write to a file first, you are writing values from, okay, 1 up to 10, something like that, and then you read it back. So therefore, you get 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay? And then when you try to read it back, we use a file input stream. Remember that the file input stream can be passed an input parameter that consists of the file name. So if you don't specify anything, it will look for this file in your default folder. Your default folder will be your default project folder. If, let's say, you created a project folder called Lab 8, then this will be Lab 8, all right? And not inside your /source/ let's say, resources and so on. So it's not going to be there, but rather it's in your main, right? So if, let's say, your project main path is called Lab 8, then it will be in Lab 8. So if you want to specify a subdirectory, then you just use a /, okay, /data/temp.dat. That is allowed, okay? So that's one way you can actually create a subfolder, right? Okay, but if you are going to actually pass a file output stream to a subdirectory, and that subdirectory is non-existent, will we create the subdirectory for you? No, you get an error, okay? So that's why the safest is still using the default path, all right? Okay? So the next example that we want to cover is data output stream, right? Data output stream and data input stream. theoretically, you can also use filter input stream or filter output stream that works about the same as data input output streams. Okay, so anyway, have a look at these two, right? They are almost equivalent, except that one of them will work with a buffer, the other one is basically direct, okay, with no buffering. Okay, and then filter output stream, of course, can be actually a class that you use to actually read the input stream, right? So it's actually implementing a filter on top of the normal input stream, right? And if you look at data input stream, it's actually inheriting from filter input stream, right? So therefore, if you learn one of these, it's good enough. Don't force yourself to learn every one of them, okay? So if you look at data input stream, the good thing is it's able to format the data in the right format that you want to use. Like in this case, if you want to read some data as Boolean value, then it reads Boolean. So Boolean is only a true or false, right? So a Boolean value in this case is represented by how many bits? 1 bit is good enough, right? 0 or 1. And if you read a byte is 8 bits. Okay? If you read a char can be 16 bits. Okay? And then if you read float normally will be 32-bit. If you read double, 64-bit. And if you read integer is 16 bits or 32 bits, right? So it all depends whether it's a short integer or long int. Okay, if it's long int, of course, it's the same size like your double. Anyway, right? So if you read a short one, definitely it is. Short means short integer. Okay, remember that. Somehow it's not saying that this is a short int. Short int, you only get half the size, 16-bit, right? And then if you read a line, it means you are reading a series of string until a new line, okay, or a new line character, right? So this will allow you to read one whole line of data. And if you read UTF, what's UTF? So our Unicode text is normally called UTF-8, right? So the word read UTF is used to read the Unicode text that you have. And because Unicode text can actually be varying in terms of the length, okay? So therefore, you have to know where to start and where to end. And if you look at Unicode encoding, the very first 2 bytes normally will be used to say what type of Unicode text format that you want to use, all right? So therefore, if it's like, for example, one string that says hello, the front 2 bytes will be the Unicode encoding, right? It represents the Unicode encoding, and then the rest will be HELLO that follows, all right? So if you want to know more about the UTF format, please look up from Wikipedia and so on, and then you can see the varying size UTF code that's available, all right? So next will be writing. In fact, you can write any kinds of format using the data output stream. So the one that we normally would try to use to write and read, the more flexible ones will be data input stream and data output stream, right? You can read and write in any format that you want from a file, right? A binary file especially, all right? And then UTF-8, as I mentioned, these are Unicode, right? And then, okay, it can be of different size, okay, whether it's 1, 2, or 3 bytes. So this will be alternate schemes. So if you use ASCII, of course, it's the most saving because it's English, right? And standard keywords that you have on your keyboard, all right? Up to 255 value, right? That means 8 bits only, right? Okay, so next, okay, for your data stream, in fact, this is one example for creating the input and output stream. Remember that for data input stream and data output stream, you will need to create a data input or output stream using a file input stream or output stream. So that means, can I just say I want to pass a data input stream with a file name direct? Not quite, right? So if it's a data input stream, it expects stream as the input parameter, right? Same thing, if you want to create a data output stream, you must specify a stream as the output parameter, right? So it cannot be you use what we have previously, file, right? Instead of file output stream. You think that file can work? Try it, then you'll notice that it doesn't work, okay? Right. So over here, this is an example of reading and writing using our data output stream and input stream. Data output stream is used to write heterogeneous data. So you write John first before you write the result of John. Jim, number second, right? Second, and then followed by the result of Jim, and then followed by George, and then the double result as well. Okay? So if you try to read it back, you have to know the format. That is the challenge, in fact. Okay? So after you have written this file, if you try to read the data in a different sequence, like for example, you read double first before you read UTF, you are going to get erroneous data. Okay? So remember that it must be the correct format. If not, then you get a wrong output, right? Or wrong result. You won't be able to get back John 85.5 later if you read it in the wrong sequence. Okay? So remember that. And we also mentioned that for input, we need to check for end of file symbol. Okay? So you can use this input.available to actually see whether there are any additional input available or not. Or the other one example that is given in the tutorial is when you use the read method, right? And then you assign it to, let's say, an integer variable, and then you check and see whether they are equal to -1 or not. If it's equal to -1, it represents an EOF, or end of file symbol, right? So -1 is used to represent end of file. And if there's this case, then it says that the files are not available, right? So if you use input available, then you check for a value 0 instead, okay? So remember that. And then this is the sequence of inheritance. You notice that we have input stream and output stream, right? Both. And then input stream can be inherited by file input stream, okay? Filter input stream or object input stream, okay? And at the same time, your data input stream is actually inheriting from filter input stream. So if you know one of these, you more or less would have covered the features of filter input stream, okay? And then the other one is called buffered input stream instead of data input stream, right? So this one, you can see that they are more or less almost similar to data input stream, except it creates a buffer. That means a temporary storage, right? For the continuous reading. As compared to here, when you read, you are expected to read the entire thing. If it's too long, it will wait, okay? So that's the idea. Okay? So remember how the concept of pipeline works. If you have a file, external file, the very first step is you are going to extract the file content using file input stream. And then after that, if you want to format the data will be formatted by using a data input stream library, right? So this library will help you to actually visualize it. Let me just change the display screen to here. So this will be how it looks like, okay? Just now you don't see my cursor, right? Okay, so that's the idea. In fact, if you look at it, initially it's binary format, right? 01, 01, 01. But when you use the libraries and also the methods inside your data input stream, you can format it to integer, double, or string, right? So because you can read int, read double, read so on, right? And then it makes your life easier so that you don't have to actually format the things on your own. Same thing for external file. When you write to it, you have the write double, write string, and so on, or write UTF that allows you to write to that file in the right format. And then it will automatically convert into binary streams using the file output stream, okay? And then towards the end, you get that into your physical file. So all these are libraries created in Java for your convenience, all right? And then for buffered input stream and output stream, it has an additional buffer layer. So the good thing is, whenever you encounter a long wait when you read a file, it doesn't wait, okay? It will wait for the buffer to be filled up, but at the same time, your program can actually continue to do something else. But that is provided that you use threading. If you don't use threading method, then your input-output will still be in a single thread. That means it will wait, okay? Right, so hopefully you get the idea. And then a block of data can be actually read using the buffer input stream, and then after it completes the reading, then it will pass over to your individual program. For writing, of course, you can just write to a buffered output stream, and then as long as the
so-called read-write device is not ready, okay, your storage device is not ready, it will maintain the buffer, right? And then you will slowly write to your file. So the buffered output stream is useful to actually reduce waiting time, right? Because you don't have to wait for the completion of your read-write to take place. If you're writing to, let's say, a very slow device, then you will notice that this will be a long wait, right? But comparatively, if you look at the input-output devices now, especially your storage device, they are very fast, right? You have your solid-state device, you have your hard disk, and so on. That is very quick. Not like last time where you have a diskette, okay? Right. So copy file, I think this example is given in your lab. Please have a look at your lab, right, in order to know how to do this, okay? So this is using the command line to run your app, but I don't encourage using command line nowadays because you can actually run it from your graphical user interface rather than just having trouble trying to compile and execute, right? So you will compile using JavaC, J-A-V-A-C, followed by Java to run it, right? So over here, if you want to run this copy program, you will have to say Java copy. This is your program name, right? Your copy.class should be there. And then next, you are going to copy two files. Input file will be welcome. Output file will be temp, okay? So all these are troublesome, okay? And if you want to see how it works, have a look at the one in your tutorial, right? The tutorial will cover everything. And then for object input output stream, this is the one that I think will be most interesting because this part will allow you to use whatever methods and attributes that you have already created in your class and save it entirely into your persistent storage. That means you save the entire content inside your memory into your storage. Okay, so this will be good in that sense, okay? So don't worry about all this arrow here and there. We are not going to look at that, but we will look at some examples shortly, okay? So the object input output stream will allow you to actually write the entire class. So examples are given in the tutorial. Please have a look at the tutorial, okay? So unfortunately here, there's not much to explain, right? If you look at all this example given here in the slides, they are too vague. So I might want to just point you to the tutorial. So let me just go back to the tutorial. And I'll show you the source code for that, okay? So if you look at your tutorial 8, binary file I/O, in fact, the most useful ones will be here. As I mentioned to you lastly, we have one that works with your object, right? Object input stream and output stream. So in order to use object input and output streams, make sure you implement a class with serializable, okay? With the serializable keyword, that means it is able to be saved as binary continuous format, right? And using serializable format, you can even transmit it over the internet, right? So we are going to talk about that later. So as long as you have a class that implements serializable, you might need to actually have a method that converts the entire serialized data into string. So over here, it's encouraged that you implement this to string, but at the same time, you can actually implement your own method, like let's say get name, okay, get age, and so on. And then because the entire content available in your class will be saved into memory, when you read it back, you are able to use the methods or the associate methods when it's actually assigned to that particular class. Like in this example, okay, I created a person object, okay, by initializing it with a new instance of person, and I pass in two values, John and 30. So then, after that, I will be able to use, okay, the method to actually, okay, over here, once you have this object output stream, I'm going to write the object of person to the storage, right? So if you use this method, you are writing the entire content of your class, including your name, age, okay? So it's not just storing
your values, okay? It stores also the class object. In this case, string name is also being stored. And then the string age also will be stored. Integer age will also be stored. So that means the type as well as the variable name will also be stored in your memory, right? And then it stores everything. And after that, you will be able to actually access it. Because over here, after you have actually created the output, right? When you read it back, you will normally use object input stream.read object, right? And then because you are reading the object and trying to assign it to another instance, a new instance that you create, then you need to actually perform a casting. So the casting is required, okay? So you need to cast it to person, because if you say a normal object, you don't know what type that is, right? You have to cast it to person type in order to assign it to a person instance variable, in this case called read person, right? So this read person, in fact, can be used as follows. If you say read person, if you have a method that allows you to get name, you can just use it here, like this. And it allows you to immediately use that particular variable that you have actually stored in your file, right? So this makes it more convenient, right? So I'm just trying to highlight this one for you so that you know that instead of the conversion or the so-called split data and whatsoever not that you have just now, right? What not that you have, it's easier, right? By reading or writing an object, okay? So if you write an object, when you read back the object, you can apply the method, okay, onto that particular object, right? The class, right? Using the class methods, you can actually get the name from that object, right? And then using the class variable also, sometimes it might be available if, let's say, the class variable, in this case, is public, right? If it's public, you could have actually have something like this, readPerson.name, okay? ReadPerson.name may be available, okay? I'm not saying that it must be available, right? So you could have actually used this variable directly, okay? If it is declared as public. But normally, we don't declare that as public, right? You use a getter or setter to get the value, right? So to get the value, you need a getter and setter. So if it's public, you could have actually used this, right? ReadPerson.name, which is even shorter, right? So do you get this? Hopefully you get the idea. In fact, I've explained about this thing in the recorded tutorial, okay? So I don't want to go into too details about this thing. Let's come back to this part. All right, so hopefully you get the idea. And next, the serializable interface, okay? So no objects can be written to the output stream. Objects that can be written to an object stream must be serializable. If you don't implement serializable, you cannot write to the file, right? So that's why you have to have this implement serializable in order to be able to write. And if you don't implement this method, just now the toString, it will still work, okay? The toString, if you don't implement, you can still work, because as long as you implement serializable, it can be written, okay? But how to read it back? Of course, you need to have the toString, right? If not, then you won't be able to read the content back to its normal form. So the class that can actually be written to your binary storage must implement serializable. Okay, so serializable interface is a marker interface. It has no methods, so that's why it's easy for you to actually use. All right, and implementing this interface allows your Java serialization mechanism to automate the process of storing the objects and arrays. Okay, and then apart from the serializable, there's also another keyword called transient. Okay, so if, let's say, your file contains, or your object contains things that can be serialized and things that cannot be serialized, so what should we do? Okay, so you can use a keyword transient to mark that one. All right? So if it contains non-serializable instance data fields, so then we actually have to enable the serialization by marking those that cannot, okay? To tell JVM to ignore those fields when you write the data. So example will be given here, okay? So if you have one that says, okay, so this A is another class, right? Okay? So remember that primitive data types like integer, static, double, in this case double, can actually be serialized, right? But if you look at, this is, okay, an instance of another class, right? Private A, okay? A is another class. Then you have to mark this as transient so that it will not be recorded, right? So this V3, in this case, is a new instance of a class called A. But unfortunately, is it serializable here? No, right? Because you don't know what is A unless you have that, right? So is that clear to you? So you can actually mark a keyword transient, right? A transient keyword to say that this, please ignore, all right? Please ignore. So therefore, we don't keep it here, all right? So when an object of the full class is serialized, only variable V1 is serialized, okay? And then variable V3s are not serialized, okay? It's not serialized because it's marked transient. V2, will it be serialized? Why? Because it's static. So remember that a static variable is not going to be serializable, okay? You don't have to mark them as transient. It's automatically implied, okay? A static variable only has one copy in your memory. No additional copies will be made available, all right? Do you get it? So therefore, this is the case. If you have a static variable, then the static ones will be not serializable in that case, okay? Right, so how do we serialize an array? Example is given. So an array is serializable if all the elements are serializable. So that means you have to check the elements one by one. Inside the curly bracket, okay? Then you have the comma, and you check the items whether they are serializable or not. Usually, numbers that are actually of same format, like for example, integer, double, float, or whatsoever, right? Okay, they can be serialized. And if you have, let's say, objects, then it won't allow you to serialize that particular part, okay? So arrays can be serialized provided that the types are known, okay? The types are serializable in the first place. Then the random access files and file pointer and all this, okay, the RAF, okay, random access file and so on, will be covered in the next tutorial. Don't worry, okay? In the next tutorial, we are going to cover that. So I will do a recording for that one as well for random access file and IO streams. So therefore, we can actually end our topic here, right? So that one will be in tutorial 9 on week 10, next week. So then we'll talk about random access file. Don't worry, okay? So the random access file allows data to be read or write in a random order, okay? So how to read and write in random order, that one will be shown in the example later, all right? So it allows you to actually do a lot of wonderful things. Like I can advance my file pointer and read and write in certain order, in certain area, all right? Okay? So that is actually covered in the tutorial. Don't worry. Okay? So we'll stop here. And for those who have not signed in, again, please sign in. And we'll end here. If you have any questions, feel free to ask. If not, then feel free to leave the class. But make sure you sign in for your attendance. If you have any problem of registering your attendance, come to me ASAP, right, so that I can help you.